technology that is ready in 12 months. Emissions reduction. Flylogix Limited. Remote methane detection. The UK oil and gas industry is committed to halving operational emissions by 2030. Eliminating methane leakage will be crucial to achieving this target. But with limited capability to measure methane emissions from individual offshore assets, current reporting is based on estimates, creating significant measurement uncertainty. Flylogix, in partnership with SEAWATER, is developing a methane measurement and quantification technology, which is integrated with an autonomous unmanned aerial system. The fixed-wing drone is mobilized from shore and can fly up to 600 kilometers to an offshore facility. Once there, it remains outside the 500-meter exclusion zone to avoid disrupting operations. Measurements are taken using a highly sensitive miniaturized laser spectrometer. In a single flight, the technology captures over 90,000 data points of methane concentration. Data is fed back via satellite to enable real-time viewing. Further post-flight analysis will determine the methane emission rates from the facility, which can then be used to validate bottom-up estimates. Low-cost methane monitoring will enable operators to accurately measure and report on emissions. With no need for surveillance flights, it is a low-carbon solution and up to 65 times cheaper than other options, such as installing cameras on assets. A one-time deployment with Flylogix could save £35,000 per asset and potentially £4.4 million annually across the UKCS, assuming a 25% uptake within the industry. Energy System Integration. SHIP Limited. Hydrogen from seawater. To meet net zero targets, the UK requires a 10-fold increase in hydrogen production. Today, commercial electrolyzers can only produce hydrogen from highly purified water. We need an electrolyzer that makes this possible using seawater. One that can be combined with renewable energy sources, such as offshore wind, so that green hydrogen can be produced offshore and at onshore coastal locations. SHIP has developed a 3D printed membrane-free electrolyzer. It produces green hydrogen direct from seawater without the need for energy-intensive desalination. 3D printing significantly reduces the unit's manufacturing costs, while being membrane-free significantly reduces operational costs. SHIP's technology also produces a range of valuable non-toxic co-products, which create additional revenue streams, and in turn reducing the cost of hydrogen. The system is automated, wireless-enabled, and ATEX certified. SHIP could revolutionize the economics of hydrogen production, reducing the production cost of green hydrogen by at least 50%, while producing valuable byproducts such as silica, which is estimated to be of over $13 billion market worth over the next decade, creating a competitive advantage in the £100 billion green hydrogen market by 2050, and opening huge export opportunities. Offshore Energy 4.0. Corrosion radar. Remote monitoring. To meet the UKCS emissions reduction targets, we need to reduce unplanned shutdowns. To achieve this, we need digital solutions to accurately predict, monitor, and detect failures before they occur. Industry research suggests that corrosion under insulation, known as CUI, leads to many unplanned shutdowns. CUI results in 60% of pipework failures and incurs 40 to 60% of pipe maintenance cost. As CUI can be difficult to detect and insulation removal is expensive, we need solutions that create smart, fully digitized assets that continuously monitor asset health to optimize plant performance, reduce risk, and lower operating costs. Corrosion radar will enable operators to adopt a smart, remote monitoring aimed at managing failures associated with CUI. The technology consists of a long, thin, flexible sensor, which can be installed without the need to remove the insulation. Permanently installed alongside a pipe or any other complex structure, specially coded electromagnetic signals are sent through the sensor. The reflected signals are then interpreted using proprietary algorithms to locate corrosion. The system is automated, wireless enabled, and ATEX certified. This smart solution will help reduce the carbon footprint of UKCS operations by eliminating fugitive emissions and reducing unplanned shutdowns. It will increase safety and reduce the cost of inspection by 50% compared to manual strip and inspect methods, delivering a potential cost saving of £130 million annually to the UKCS.